Well, I'm doing a test fit here of the major components, and as you might be able to tell, I'm missing a piece. I'm missing the center of this back support. I tried to print that all as one part, and it just got to be too much, and I had troubles, as you can see. So I lopped off the top and the bottom, and now I'm printing the centerpiece with the locking handle. And as soon as that's done, then I bolt these all together, and then I can assemble this and turn it on and try it. The idea is we're going to use this motor here with the screw in it, and that'll raise and lower the spindle up and down. And that's what happens when you try to do everything at once. That'll raise the spindle up and down, and these axes that I already have, they're kind of small, but they work. They have an X, or that's the Y, this is the X, and I can use manipulate those by hand. And what I really want to do is, you see there's this slot inside this metal. I need to make that slot inside that chassis right there. I use that slot for a gear that helps me do other things, and if I don't have it, it's really hard, or it's impossible to use my other technology that I want to work with as far as puffing and chuffing on the engine. I know, it sounds like, oh, Dennis, what? No. Well, this is what I do. All right, I make trains do things that they can't do, or I want them to do, and they never did, so there. So I'm going to put a slot in here, and what I wanted was a good machine that could go straight, strong, and consistent, so I can do a lot of these, because I have about 10 of these chassis. And the way I did it before was basically by hand, and this gizmo, as it was very flimsy and would wiggle and chatter and carry on. And I thought I really need to have a better system. And I found a fellow, young engineer in Poland, who had built this conversion. They also have these, what they call Dremel machines, and he made this carriage for it, and he added these rods so that it can go up and down, and a jack screw that you can turn with a little motor. So over here I could have a handheld, and I could tap it down and up and put it where I want it, and then these things, initially I'll crank them in and out and where I want them to be, and then we'll be able to machine parts on here. As soon as I get this centerpiece down and bolted in, I'll be able to show you better what it's going to do and how it's going to do it. But right now I'm just test fitting things, seeing how it's going to work. The motor's going to turn this screw, and then this screw, see how the piece can go up or down. All depends on what you got and where you're going. It'll go up or down, and then I can raise it and lower it and all that. Okay, so, and I'll get tool bits. I've ordered bits for it that will mill out aluminum. This is really cheap metal, so it'll cut pretty easily. And so that's what I've been doing for the last 4 or 5 days, is designing this adapter, because he didn't build this exactly the same. He had a whole machine, and I didn't really want that. I just wanted the head part adapted to my current drill press. This is not heavy duty. This is not industrial. This is DIY, hobby man, trying to get things done, basically. So we will see as the worm turns if this is going to do it or not. I'm hoping it'll at least allow me to do that slot, and if I'm successful making the machine that can do the slot, then I might get a bigger X and Y table and put motors on them and actually build what's referred to as a mini CNC milling machine. That's exciting. Okay, so here's the part that's being built now. That's will be the center, and the 2 other parts will bolt to it, and it'll bridge that gap, and it'll have what we had originally on the other one, this locking device in the back. that allows you to slide the whole mechanism up and down in like a coarse vertical adjustment, lock it down, then you use the motor for the fine adjustments. And you can use the motor while you're machining out. So if you're cutting down in, like I'm cutting down into that slot with a drill, right? I'm cutting down, let's say I'm cutting down into this hole, I'm cutting down, and I can move it back and forth, in and out. Then I want to come down more, I put the motor on, and come down a little more, and just keep milling this thing out until I got the shape I want. It'll be manual at first with the vertical axis with the motor, but I intend to make that all I don't want to say automated, but CNC. I can take the CAD file, the design of the pocket that I want, and then use that as instructions for the machine. Give it the diameter, the speeds, the lengths, the rates of change, and it will guide the mill end where I want it. And so I put the part in, I index everything, and then I just say, make my slot, and it does. Makes a slot. I hope. That's the objective. I know, it's a long way to go, but it's what I need to do because I really want this gear. This gear right here has given so much to Leon's engine. I want to do it on these other trains. And the only way I can do that is by cutting the slot. The other piece that I've been working on is this board and this chip, which has been phenomenal. This works beautifully. It gives us everything we want, basically, everything we want. And I'm going to be building the handheld, which is here. We printed it out, and then I had trouble getting some of the schematics. So I have the schematics, so when I get done with this project, then I'm going to come back to this one. I'm going to put in the chip and the screen, and we'll have a handheld controller for Leon's engine, which will have fan-driven smoke. It'll have puffing. It'll have chuff sounds. And it'll have digital control. So I don't know. It should be pretty cool. It should be pretty state-of-the-art and pretty cool. And I have some other sides for that. So this will be pretty exciting. I'll get back to it probably Monday or Tuesday. I'll get this all buttoned up today and tomorrow, and then we'll be able to machine new K5s, Hudsons, anything that did not have the slot. And then my next objective was to consider what would it take to machine the whole chassis out of a block of aluminum. You know, if you had a 2-inch by 2-inch block of aluminum, what kind of machine would it take to make your own chassis? That's been part of the problem all along, was we have this beautiful S-scale, we have these great bodies, but we don't have chassis, and we're running out of chassis. And so, you know, we try to keep them and update them and all that, but frankly, if we're running out and we could print our own, what I'm thinking I can do is I can cut out of aluminum this shape, then flat sides, and then screw onto the aluminum the 3D printed motors and gears and parts that will hold the axles in place, and the aluminum will be like the core structure of the chassis, and then all the ancillary functions can be put on with 3D printed parts. It doesn't get that hot, so it should function, and the aluminum would give it a mass and some strength in the core. So that's the idea. That's why this project seemed to be, for me, kind of important. If I can get this to work, I can make that groove. I can prove to myself that I can make a groove. I can now machine an axle hole and smooth it off, put in the bolt holes necessary to screw on the aluminum, or aluminum or plastic screw on. I'm thinking it's going to be plastic parts to finish the engine chassis complete. Ball bearings in the axles if you want them. We can then do that because we now own the chassis. We build the chassis. And then there's only, a 2-axle, 3-axle, 4-axle chassis for all of the American Flyer engines. Now then, here's one, see that? Now then, if you wanted to build a 4-wheel or 5-wheel drive steam engine, which had never been built, now we could do that. That'd be pretty cool. Articulating, if there was some kind of an interface you had to build where they would pivot, I could machine that. So I think the desktop DIY mini mill would be pretty cool. Once I get this thing ironed out and it's functioning, I'll try to automate these guys with the wheel, take this gear off, put the motors on. If I find this is just too undersized for what I want to do, and it may be, I don't know, okay? There are bigger ones, and you can just buy them and put all the stuff on it. So you just like upgrade the slide tables, X and Y tables, and go back to work. If I find this piece here is too flimsy, so you can see I can move it. You see that, right? If that's too flimsy, I may try to tie this piece down to something over on the side, like I did on my printer, the struts, we call it the Z-axis struts that go out and down, gives it strength from the top. So you could come in from here and go down to here, or maybe backwards, maybe go back. I could mount this whole, right now it's bolted to my table, but I could mount it onto a big piece of board. The kinds of board I have is this 3/4 thick plywood that's on this train table, which is extremely strong and stiff. So I have pieces of that somewhere around here, and I could build that platform for that. So it could be a totally, single, pick it up, move it from here to there kind of a thing. It's a DIY. I'm building it myself. It's a mini because it's very small and lightweight, but it would have the CNC functions, the stepper motors and sensors and stops and screens, and it would take my CAD files from my Fusion 360 design work. So what I would do, I would be on here and design the slot or the CAD or whatever I wanted to do. And instead of bringing it over here for 3D printing, there's other software, what I call post-processing, that you can do that will create the G code for a CNC machine. So what I would do is capture this shape, the center, the hole. See here, I'm adding material to get a solid, but now what I'm going to be doing is removing material to get a cavity. It's different. So the tool would do that. You would go from a solid to something else. You may go like to manufacturing and look at milling, and you'd go to a setup. You'd set up your machine parameters, and then you could create the program, put the part in. This thing has more power than I dreamed about, and I'm learning it. I knew it had power, I just didn't have the machine to need it. But now, with my new friend in Poland, we have an idea for a machine plus the 3D printer. So I can do additive and subtractive material manufacturing. So it's that beautiful finish on that red. Boy, does that look nice. I got to look sharp over there, cutting metal away and all that. Okay, well, that's what I've been up to. Thought I'd share that, let you know. Yeah, I'm still working on trains a lot, but I've had an interruption, and I'll be getting back to, well, one thing I got to get back to is cleaning up, you know that. But I'm going to get back to Leon's, the remote control, and everything else that goes with that, and building trains. My goal is to build trains. I needed a tool to help me to do that, so I'm trying to build a tool. This may not be interesting to most of you, but I just thought I'd let you know I'm alive, I'm doing things, and I haven't posted much because I've been busy doing this. Okay, hang in there. Later.